Today we're going to talk a little bit about continuous application security. Now, in most organizations, security is not continuous. And even just saying that sounds weird. Like, why would you do security on, in intervals? We're going to focus on making sure that you can get security all the time. And like continuous integration and continuous delivery, I think continuous security ought to be part of every software organization. So today we're going to focus on how do we achieve that. I'm going to start with a couple of facts about security. So this iceberg here represents the typical application. And the chunk of the iceberg below the water represents all your libraries and frameworks and so on, components. The stuff above there represents custom code, the business logic and things that you write. And what's interesting is there are vulnerabilities in both pieces, right? There's CVEs or known vulnerabilities that people discover in the libraries. Those are pretty frequent and they've been in the news a lot lately. Typically, an application will have one or two of those. On the top part in the custom code, the typical application has 26.7 vulnerabilities. That's a pretty scary number to me. And this data was gathered across tens of thousands of applications over the last couple of years, by the way. And I mean, would you fly on a plane if every time they did an audit, they found 26.7 safety violations? We're not doing well enough. There's some serious problems here. Now, one thing that's interesting that you don't hear a lot about is that most of that code on the bottom half of the iceberg never gets called. 72% of your libraries and frameworks, that code never gets invoked at all. So when you're remediating those vulnerabilities, just keep that in mind. If your code's never called, you really don't have to update it. It's not a priority. You should still probably fix it, but it's not a priority. This is some data gathered from real applications, again, about 10,000 applications, showing from last month the number of attacks. And what you should get from this is that your application is very likely to be hit by numerous different kinds of attacks every month. So more than half of the applications here, 53%, were hit with SQL injection in the last month. So there's a pretty terrifying amount of attack data. Many applications get hit with millions of attacks every month, and most organizations don't see them. They're not visible. In a way, they're kind of blind to those attacks. So we got a problem, and really fundamentally, I believe it's because the tools that we use for application security are very inaccurate. Static analysis and dynamic analysis and WAFs are all very inaccurate technologies. And when you have an inaccurate security technology, you have to have security experts involved. You have to have security experts to go sort of weed out the false positives. You have to have security experts to go identify the false negatives. Those are the real vulnerabilities that you missed. So when you have a process that has to have experts involved, it just doesn't scale, right? So you've got a big portfolio of applications, and you're spending a lot of money, and you have to drive it through this bottleneck, and the results that you get on the other side are weak. You're not going to get good assurance because you're going to miss a lot of stuff. You don't have a good process fit because these tools are essentially incompatible with modern high-speed software development. And you'll get bad coverage over your applications. Every organization I know prioritizes their application portfolio. They only do application security on the critical ones, right? That's really dangerous. Most of the big breaches are not through the main front door web applications. They're from business apps and partner portals and things that don't really rate in terms of criticality. So we've got a serious problem here. DevSecOps, I think, is very promising. I'm not going to spend a huge amount of time on this today because it's a big topic, but essentially I think security needs to reinvent itself the way that development did. And so the path, I think, was charted out for us in the Phoenix project. If you look at the 3 ways of DevOps, establishing workflow, creating instant feedback, and creating a culture of experimentation and learning, those are 3 things that security just doesn't have today. Security doesn't have great workflow. People do giant security tasks like a security review where they look at everything. They don't break the work down into little pieces and do it as part of the normal flow, so security gets way off track. We don't have instant security feedback, so there are these long feedback loops, like sometimes years, between when a vulnerability gets introduced and when it eventually gets fixed. That's terrible. And security culture is a complex thing. Most organizations that I see, there's a little bit of friction between the security team and the development teams. I'm gonna say it's not always perfect. So those are kind of the challenges that we need to fix. I'm gonna focus today on technology, what we can do in the pipeline to try to make application security continuous. It doesn't fix all of these issues, but it's a good start. So what I'm gonna try and do is show how we can create continuous application security in 3 areas. In development, I want to empower developers to find their own vulnerabilities, make their own fixes, and check in clean code. That means the feedback has to be instant, it's got to be super accurate, and it can't slow down the developer, so no extra steps. How's that sound? Does that sound good if we could do that? Okay. In integration, it's a little different here. I kind of want to have a double check, right? So that I'm sure that everything I push into production is we've checked it, we've got everything lined up, or if we have compliance requirements, we've hit those. But I don't want to slow down the build. I don't want to have to use different tools, and I want the possibility of breaking my build if there's a critical security vulnerability or something. So that's a little different. And then in production, I don't want security to just stop when the code goes to production. I want security in my production environment. There, I want to know who's attacking me, how they're attacking me. I want that threat intelligence. I want to stop those vulnerabilities from being exploited. So it's not enough to just know about them. I want to actually stop them. And I also want to avoid that alert fatigue. So again, accuracy is critical. I don't want to overflow the SOC with nonsense attacks. So if we do these 3 things, we've got a good head start towards achieving that continuous security culture. So I'm going to show you how we can do that. And I'm going to rely on 2 relatively new technologies. So traditionally in security, we have SAST, or static analysis, for analyzing source code, and we've got DAST, dynamic analysis, which essentially attacks web applications to find vulnerabilities. I'm going to talk about IAST, or interactive application security testing. It's a new way of finding vulnerabilities. And then I'm also going to talk about runtime application self-protection, which is sort of the operational side of things, where traditionally we would have relied on something like a WAF. So IAST and RASP are a little bit like App Dynamics or New Relic, but for security, not for performance. So the way they work is you take an agent, like for Java, it's a jar file, and you add it to the application. So this is, it's a Java agent. And that agent instruments the application for security so that when you do your normal testing in your local environment or your QA testing, it's in the background watching that application run and adding security testing invisibly to you. So for example, on the top line here, the developer just maybe fills out a web form with normal data. You don't have to attack the application, just normal data, like the word Jeff, hits that. Now IAST actually tracks all the input from the HTTP request, so all the headers and cookies and form fields and so on. But just imagine one here. It tracks that data through the application, and sort of imagine we're looking for SQL injection here, for instance. It tracks that data through the application, and when it lands in a SQL query, the IAST agent checks back across that path and says, hey, was this data escaped or parameterized in some way that would have stopped SQL injection? And if it wasn't, then we know we've got a vulnerability. And we've confirmed it because we actually watched it execute. So it's far more accurate than sort of legacy technology. And it's kind of the same thing for RASP. There, that same attack, now it's a real attack, right? So like, think or 1 equals 1 or something here. And the agent tracks that data through the application, and when it lands in a query, the agent can actually analyze that query and see that or 1 equals 1 modified the meaning of that query, and only then intervene to prevent it from being exploited. So again, very different from traditional static and dynamic and WAF kinds of technologies, and much easier, much more compatible with continuous application security. So today what we're going to do, and I've got just about 20 minutes to do this, so we're going to move fast. We're going to take this pipeline, for Spring Pet Clinic. And you see we've got a development environment, a CI/CD environment, and an operational environment. And we're going to enable, in the dev environment, we're going to enable IAST, so we get instant feedback through the tools we're already using. Then in the CI/CD environment, we're going to use IAST and RASP, and we'll get feedback through the tools we're using there. And then in production, we're going to deploy to PCF, and we're going to use RASP to make sure that our application is protected against attacks. And we're going to do it all in about 20 minutes, and you guys can do it to your applications in about that same time. So this, by the way, is, well, I guess we'll get to this in just a minute when we get to production, but it's really easy to add. Okay, so I've got 3 environments here. I've got a development environment, I've got a CI/CD environment, and I've got a production environment. And I've helpfully labeled those environments so nobody gets lost during the presentation, because it's a lot of different screens, right? So in development, I've got STS here, and I'm developing my application, and I want to add contrast to it. So the first, I'm going to use contrast as we have a community edition that's free and open to everybody. It's IAST and RASP agent, so you guys can try this stuff out. You can use other IAST and RASP products if you want. This is just easy for me. So the first thing we need to do is sort of get the agent. So I would sign up for an account, download the agent. It's super easy. I won't go through that process. It's exactly like New Relic. And then we have to add it to our application. So I've got the jar file here, and I just added it to my project. You can actually add it anywhere on the disk. And then I've just got to tell the application to use it when it runs. So I'll pull up the POM, and you can see here in the, this is a Spring Boot app. And so in the configuration, I've just specified the Java agent flag here, and a few other options just to tell the IAST tool what the name of this app is and things like that. And that's it. From now on, every time I run this application, it's going to run with this agent in the background, and it's going to automatically detect vulnerabilities in the background and report them. So I've got the application running here, and before the talk, I cleared out all the vulnerabilities in the dashboard. So it's just empty. You can see the contrast plugin down here. There's no vulnerabilities. All you have to do is just browse around in this application, and I'll just put in Spring 1, exclamation point. You can add an owner here. And up here, you're going to see new Slack alerts coming in for new vulnerabilities as we find them. And again, I don't have to really do anything here. I'm just using normal input. So I think this is important because a novice developer can now do this and find their own vulnerabilities, check in clean code. So we're just browsing around, like we just hit these pages. We don't have to do anything special. Now, I'll refresh my plugin here. And what we'll see is that we've discovered, I don't know, 6 or 7 new vulnerabilities here. And I'll zoom in so you can see the list of them a little bit down here. But some of these are actually pretty tricky vulnerabilities, like Hibernate injection and stored cross-site scripting, parameter pollution, and things like that. So when I drill into one of these, like I'll look at the Hibernate injection flaw, and what we'll see is we get an overview of this vulnerability with all the details. So here you can see a little bit of the HTTP request that I entered. You can see I typed in Spring 1, that's right here. You can see that was accessed in this method, on this line of code here, and actually ended up in this Hibernate query here. Now, the only reason that this IAST tool reported this was because that data was not escaped anywhere along that path. It didn't go through a parameterized API, and it wasn't escaped to make it safe. So we know that this is an exploitable path through the application. So that's quite powerful. We also get details on how to fix, and we get all the details of this vulnerability. We can drill down so we can see the exact line of code where this parameter was read in. You get the exact lines of code where this query was built, even the exact line of code where this was sent to the database in a full stack trace. And for any of these, you can drill down and double-click and go right to the line of code where that vulnerability exists. So now I know exactly where I need to make this fix, And you can see right here, this is where the, the concatenation happens. This is the query that's at fault. Okay, so a couple other things. In this case, you get a dashboard for every application, and I'm going to zoom to that. So I'm going to go to this Spring Pet Clinic dashboard. This is my dashboard for this application, and because it's IAST, this is always up to date. So I want you to get out of the mindset of thinking about scanning as a sort of a step. Instead, IAST is like monitoring your application. So it's continuously monitoring for vulnerabilities. It finds the same vulnerability hundreds of times a day and keeps it always up to date. So this is, you've got a real-time dashboard here for all your vulnerabilities, and you see we found 6 vulnerabilities. The other thing that's important is that the IAST also analyzes all your open source code. So instead of trying to read it from the POM and figure out what's what, IAST actually measures the actual application. So when classes get loaded, it looks up the jar it came from and reports and says, hey, this is a jar file associated with this application. It checks the current version you're using, the latest version that's out, and even tells you how much of that library you're actually using. So you can see most of these are zeros. And if I drill down into one of these, you can see details of any known vulnerabilities associated with these libraries. So in this case, you probably want to update this library. If you're using it in multiple applications, you can see exactly what apps it's in and what servers it's running on, so you know where to go make the fix. So the goal here is to make sure that you keep your libraries up to date. It's a pretty serious problem. Many of the breaches that attacks that we're seeing are going after these kinds of vulnerabilities in libraries. In fact, when a new vulnerability comes out, we see attacks against that vulnerability the next day. So there's almost no gap anymore. So I want to challenge you, how fast can you update libraries when a new vulnerability comes out? Does it take you weeks, months, longer? The attacks are going to start right away and kind of broad scale across all the applications on the internet. So this is actually something that you got to get good at to defend yourself. Okay, so that's essentially the development piece, right? We've got instant feedback to developers. We send it to them through they're already using. I didn't show the Slack channel here, but we also get vulnerabilities through Slack here, so you can get the details in whatever environment you want. We even have a Chrome plugin that you can use as another way of getting vulnerabilities. So here, I can see that on this page, these are the vulnerabilities that are associated with this page. Always up to date, always in real time. So this is a powerful way for folks to understand sort of where these vulnerabilities are. I do recommend that you also look at your JavaScript libraries. And there's another tool out there called retire.js. I have the Chrome plugin for it. And it's nice, it's powerful. It will tell you all the JavaScript libraries that you're using that are out of date or have known vulnerabilities. So I recommend that you use retire.js. You can also make it part of your build, but this is an important way of seeing when you got out-of-date libraries. Okay, and the last thing I want to demonstrate here in the dev environment that this vulnerability is actually exploitable. So normally when I use this, I can just type in a name like Davis or something and look up an owner. But if I attack it, I'll put in Davis or 1 = 1 here, and I can steal all the data out of the database. This is quite powerful. That's because I'm only running IAST in this environment. I'm not running RASP. So we'll get to RASP in just a second, and I'll show you how that works. Okay, let's move to the CI/CD environments. Here, I've got Jenkins running, and sort of every time I do a build, and that's Jira. Every time I do a build, I'll start a build now here, my test cases are going to run, and Contrast is part of those test cases, and I'll show you that. In Maven again, to configure it, I've got my Surefire plugin here, and you can see I've added the jar file as the Java agent to this configuration here, so that every time I run my test suite, the they run with contrast, and any vulnerabilities get discovered automatically. So I'm going to start my test suite here just so we can generate some data in the background. And you'll notice I'm also running Jacoco for code coverage, because I like to know both that I've done my security testing and that I've covered everything in the application, right? When I have those two pieces of information, then I've got real assurance that I've tested. So we'll start seeing, as the test cases get spun up and started, we'll start seeing new vulnerabilities starting to get reported. So I wanted to show you the code coverage here while we wait for that. This is the Jacoco report rendered in SonarQube here, and it's just a nice way of I can drill down and I can see, oh, here's the exact lines of code that actually got. It's a good way of maybe augmenting my test coverage if I'm not getting great coverage over all of the code. Now, I like to be a little more formal about security during the CI/CD process. In development, I think it's fine to just give developers instant feedback, let them make their changes, and check in clean code. We don't need to create a federal case for every vulnerability that we discover in dev. That's where we want to discover them, because they can fix it for almost nothing. Once they check it in and it goes downstream, then the costs of security get much more expensive. So in CI/CD, I think it's important to be a little more formal about security, because you want to make sure everything gets closed before it gets into production. So IAST has Jira integration. So every time a vulnerability is discovered, it can create a Jira ticket. This is two-way integration, so when you close the ticket, it closes it in the IAST tool. So this is a nice formal way of dealing with security, I think, in the CI/CD layer. And again, the only way that you can really do this is if you have an accurate security tool. If you try to do this with static or dynamic tools, you'd just create thousands of vulnerabilities, most of which are false positives. So ultimately, accuracy is the key to continuous application security. And so now that we've run our test suite, I'm going to refresh my dashboard here and show you that now we've got a dashboard that shows here's what's happening in development. We found a few vulnerabilities, and maybe the developers are fixing them. But we've got a lot of vulnerabilities in our QA environment. That's a sign of a potentially unhealthy project, or at least a project that could do a little better at security, because we want to fix those vulnerabilities earlier in the dev process. So this is a nice way to sort of see security across the whole development process. When I drill down into these vulnerabilities, you'll see a fairly broad range of vulnerabilities. That's one of the advantages of IAST, is that it can find not only the kinds of vulnerabilities that a static tool might find in the code, but also the kinds of vulnerabilities that you might find in HTTP responses, things like cache control headers and parameter pollution, those kinds of things. It can even find things deep in the code, like hard-coded passwords and weak random numbers and things like that. So it analyzes the application a number of different ways. One other thing I wanted to show you quickly here was this idea of route coverage. So IAST tools can analyze the application and figure out what the exposed endpoints are. So in this case, you'll see IAST tool discovered 28 routes exposed. 26 of those have been exercised, and 16 of those are vulnerable. So the immediate question is like, wow, what routes did I not see? So I can zoom in on this and see, oh, here's 2 routes that I never hit as part of my test suite. I can pull those up and see exactly what the request is that I need to send to expose those. And when I saw this, I was a little surprised. I didn't know about this manage API. And so when I pull it up, even in production, I can pull up manage and pull up things like manage/environment, which shows me my whole environment. This kind of information is really useful to attackers. And frankly, I didn't know that this was exposed in Spring Pet Clinic. So this is kind of something that analyzing from inside the application has these huge advantages over trying to analyze an application statically or dynamically, because they would never be able to find this. Okay, I'm going to move to production now because we're running up on the end of our time. So the bottom line here is that in production, RASP, or runtime application self-protection, is preventing any vulnerabilities in this application from being exploited. So here, this is the Hibernate injection that we found. And here, if I try to exploit it exactly the way I did before, now the RASP agent intervenes, prevents that query from going to the database because it saw that my attack changed the meaning of the SQL query. So unlike trying to block it at the perimeter with a WAF, where it's very difficult to tell what's an attack and what's not, and we make a lot of mistakes, it's noisy. Here, we know this was an attack because anytime untrusted data modifies the meaning of a SQL query, we know that's the definition of SQL injection. So RASP is enforcing essentially that definition. And it makes whole classes of vulnerabilities unexploitable. Things like expression language injection, which has sort of plagued Struts and Spring over the last couple years, RASP makes that impossible to exploit. And I say impossible because what it does is it essentially wraps the expression language evaluation engine in a sandbox that prevents things like writing to files and executing operating system commands and things like that. The only thing you can do inside the expression language engine is evaluate expressions, which is exactly what we want. So quite a lot of power here in RASP, and I'll show you the Splunk dashboard here. The data from RASP goes right into your SIM so that your SOC can have full visibility into what's going on at the application layer. And frankly, you can have visibility into what's going on in your application layer too. Developers should know who's attacking you, what kind of attacks they're launching, and what URLs and apps they're targeting. That'll help you prioritize what defenses to put in place. So here you can see the details on what's getting blocked, what's just a probe, which applications are being hit, what kinds of attacks are being used. You can see the second one, that's the CVE that took down Equifax. And so, OGNL injection is we see quite a lot of that, which is a big Spring problem. And you get sort of a timeline of, when are people attacking you, what URLs are they hitting, all that kind of information. Okay, so sorry for the whirlwind tour of RASP, but that's what we're at. This is how you deploy IAST and RASP in PCF. Essentially, you can just create the service and add it to your application and then restage your app. And then from then on, your app will run with IAST and RASP agent engaged. And so the question is, did I achieve my goals? Did I show you how we can empower developers to write secure code themselves without security experts? Did I help you make sure that in CI/CD we're pushing code with assurance into production? And then did we protect the application in production? By the way, that protection in production also includes libraries, right? So it prevents even those new CVEs from being exploited, even in advance of the vulnerability being discovered. So if a new expression language injection vulnerability comes out in Spring something tomorrow, RASP can be there protecting you so that now there's no fire drill. You can take your time. I still recommend that you fix the library, but you can take your time and do it as part of your normal development process. So in the end of the day, what we've enabled here is we've gotten the security expert bottleneck out of the loop. Now, it's possible to do this at scale across hundreds or thousands of applications. Everybody's securing their own stuff. Everyone has visibility into what's going on. Most projects actually work down their vulnerabilities down to 0, and then they stay in that state, and whenever a new vulnerability is introduced, they just fix it, and they're back to secure state. And they're doing it all in parallel with better assurance. So this is the picture of continuous assurance that I want you to have in your head. All your applications done in parallel. Not scanning them one by one and getting a PDF report, but everything being done in real time with continuous notifications through the tools that people are already using. I'll point you to this Contrast Community Edition here. This is, again, free and full strength IAST and RASP engine. You can use it on one app. And it does all three things: assess, open source, and protect. And it's got a ton of integrations to the kinds of tools that people are using. And essentially what we are trying to do here is bring security to everyone in the world. There are so many developers out there that don't have access to any kind of security tools, much less good ones. Only 6% really have decent security tools. So that's crazy. That means we'll never get in front of security. We're not going to train all those developers. We're not going to do it for them. So we've got to take this approach. So we're trying to do something great for the world here and give away some good technology. That's it. So please go fast and be secure. Thanks.